Hello students, in this video we'll see an example where you have to integrate by parts multiple times and form a recursion relationship. So let's find the integral of e to the negative 2x times sine of x dx by integrating by parts. This is a problem where we're going to experience cyclic behavior. So what we'll do is we're going to let's recall first our integration by parts formula with the integral of f prime of x g of x dx is f of x g of x minus the integral of f of x g prime of x dx. So what we're going to do in this problem is we're going to let our f prime be e to the negative 2x, and our g of x be sine of x. So in our problem, f prime of x is equal to e to the negative 2x, which tells us that f of x is going to be equal to negative 1/2 e to the negative 2x. And our g of x is sine of x, so our g prime of x is cosine of x. Let's integrate by parts using our integration by parts key. So what we're going to do is we'll do one small trick. We're going to call this integral over here, I'm going to call this integral over here I for integral. So our integral I, which is the integral of e to the negative 2x sine of x dx, is equal to f times g, so that's going to be negative 1/2 e to the negative 2x times sine of x, minus the integral of f, which is going to be a negative 1/2 e to the negative 2x, and then times g prime, which would be a cosine of x dx. And so if we simplify this, this is going to be a negative 1/2 e to the negative 2x sine of x plus 1/2 the integral of e to the negative 2x cosine of x dx. And it looks like we just basically came across a very similar problem that we started with, only with sine replaced with cosine. The trick now is to integrate by parts one more time on this. We'll do the same thing over here. We'll let this e to the negative 2x be our f prime, and we'll let the cosine be our g. So let's integrate by parts again. If we do so, this first term stays the same, negative 1/2 e to the negative 2x times sine of x, then plus 1/2. My f prime is e to the negative 2x, so my f times g is going to be negative 1/2 e to the negative 2x times cosine of x, minus the integral of f, negative 1/2 e to the negative 2x, and then g prime, which is going to be a negative sine of x dx. Let's write this out cleanly. So this will be equal to negative 1/2 e to the negative 2x sine of x minus 1/4 e to the negative 2x cosine of x. And then carefully looking at the signs over here, we're going to have a minus 1/4 the integral of e to the negative 2x sine of x dx, because we have this 1/2 over here and this 1/2 over here, which turns into a quarter. I have negative, negative, negative. 3 negatives is a negative. And what we have now is we basically have just encountered the same exact problem. It cycled back to this integral. Now, here's the observation we need to make. What we have is we have our integral I is equal to this expression minus 1/4 of what? Minus 1/4, this expression over here, is exactly equal to I. So what we have is we have a relationship for I now. We have that I is equal to negative 1/2 e to the negative 2x sine of x minus 1/4 e to the negative 2x cosine of x minus 1/4 of I. So if we take this 1/4 of I with a negative sign and put it over here, that means we'll have 5/4 of I. So 5/4 of I is equal to, well, let's pull that e to the negative 2x and 1/2 out. So I have a negative factor of 1/2. Pull negative 1/4 out. E to the negative 2x. And if I do that, what we'll have over here is we'll have a factor of 2. And then sine x. And then minus cosine x. That tells me that when I take the reciprocal, the 4's are going to cancel. That tells me that our integral I is equal to -1/5 e to the negative 2x, and then 2 sine x minus cosine x plus a constant c. So we found our integral, and so what happened was when we integrated by parts once, I got a cosine. When I integrated by parts again, I got back to sine. So I basically recovered my original integral, and that allows me to solve for the original integral if we labeled the original integral as I or some other variable. Thank you very much.